So I just want to start by thanking the organisers for the opportunity to present today. I'm Jack, I'm a PhD student based at the University of Lincoln. And today I'm going to talk about a study that I carried out recently, which looks at the relationship between sequence-based motor laterality and language laterality using an online battery. And this paper is currently under review at Laterality. The study was pre-registered on OSF and the data is all openly available on there as well. And the tasks that I'm going to discuss today are all available on Gorilla Open Materials. So it's widely accepted that both language processing and motor functions are lateralized to the left hemisphere at population level. And one suggestion is that this may be due to both functions relying on the sequential ordering of information to achieve a goal. So although it's clear that there is this left hemisphere bias at population level for both of these functions, there are individual differences. And this allows us to test whether these two functions are necessarily associated. So as I'm sure you're all aware, when measuring handedness, there are two main approaches that one can take. You can use preference measures, which usually come in the form of questionnaires. And these ask individuals which hand they use for certain tasks. Or you can use performance measures, which measure hand skill and allow us to compare the ability of the two hands. And the demands of these performance measures can vary widely between tasks. So, for example, with the grip strength task, which is shown here in the image on the left, it just measures the amount of force that one can exert on the dynamometer with each hand. But in contrast to this, some tasks require more intricate movements of the fingers. And there's a lot of sequencing of movements involved in certain tasks, such as the pegboard task, which is shown on the right side of the screen. Sorry. And here I'm going to refer to motor laterality assessed using tasks that require sequencing, such as the pegboard task, as sequence-based motor laterality. And a link between sequence-based motor laterality and language laterality has been highlighted in some small non-clinical samples using both functional transcranial Doppler and also a dual task paradigm. Specifically in the dual task paradigm, it was found that a pegboard task interfered more with word generation compared to a control task, which involved less sequencing. And another key observation on which this current study is based is from Flowers and Hudson in 2013, who found that motor laterality assessed using a pegboard task was actually a better indicator of speech representation than hand preference. And this was in a clinical population. And more specifically, Flowers and Hudson showed that those with small between hand differences on the pegboard task were more likely to display ambiguous or bilateral speech representation, whereas those with large between hand differences on the pegboard task all displayed speech lateralized to the hemisphere controlling the better hand. So in other words, the hemisphere contralateral to the better hand. And Flowers and Hudson concluded that tasks that target sequential control in either language or motor functioning should show associations between performance across these domains. But most studies in this area have relied on relatively small samples, and they've infrequently explored the reliability of the tools that they use to assess lateralization. And this is particularly important when investigating the link between laterality indices, as the absence of a correlation can't be interpreted as independence of function unless each task is reliable. So in the current study, we aim to develop a battery that can measure sequence-based motor laterality and language laterality online, and to establish the reliability and validity of these measures. And then we use the battery to test for an association in a large sample. We also had a couple of additional aims, which I'll touch on briefly today, and they were to look at how midline crossing impacts the performance of each hand, and also look at the relationship between hand preference and hand skill. So to do this, we developed and administered an online battery using Gorilla, and the battery included 3 measures of motor laterality, 2 measures of language laterality, 1 receptive in nature, which was the dichotic listening task, and then 1 involving speech production, which was a visual half-field task. And we also included the Edinburgh handedness inventory as a measure of hand preference. And the study involved 3 sessions. In session 1, 621 participants completed the online battery, and then 52 of those participants returned to complete the battery a second time in session 2. This was so that we could establish the retest reliability of each measure. And also we had 32 participants attend an in-person session where we administered the pegboard task that was used by Flowers and Hudson. And we used the data from this session to cross-validate the new online task, which was based on the pegboard task. So before I go any further, I just want to touch on how laterality was quantified for each task. So we used a standardized LI, which was calculated by computing a Z-score that represented a comparison between left and right-sided responses for each participant on each task. And I'll refer to this as an LI Z-score. And this LI Z-score provided us with a common metric for reaction time and count measures. And it also allowed us to identify significantly lateralized participants on each task. And negative LIZ scores here will indicate a left behavioral advantage. So either a left hand advantage, a left eye advantage, or a left ear advantage. And then positive LIZ scores will indicate a right behavioral advantage. So we use the dichotic listening task as a measure of laterality for receptive language. And the online version of this task that we used was used previously by Parker et al. In 2021. And it was created using stimuli from the app iDichotic. And as I know you're all familiar with the dichotic listening task and we're behind schedule, I'm not going to cover this one in too much detail, so I'll move on to the next one. So the next task that we used was the visual half field task. And we used this as a measure of laterality for speech production. This was adapted from a task used previously by Brisbette in 1994. And on each trial of this task, participants are asked to overtly name an image which is presented in the left visual field or the right visual field. And the image that they have to name is indicated by a centrally presented arrow. So on the trial that's presented on the slide, there's a picture of a lamp on the left and a picture of a boat on the right. And when given the correct response, participants would say the word boat as the arrow is pointing to the boat in the right visual field. And due to the contralateral pathways, we would expect to see someone who's left lateralized for speech production to have a right visual field advantage on this task. And to calculate LIZ scores, we compared response times to stimuli presented in the right visual field with response times to stimuli presented in the left visual field. So moving on to the motor tasks, the simple sequence tapping task that we administered was developed adapted from a previous task used by Parker et al. And on this task, participants just tap a simple sequence of 4 keys with each hand. And before each motor task began, they were asked to align their keyboard so that the left edge of the G key was perpendicular with their midline. And they were also instructed to only use their index fingers. So on this task, participants pressed W, R, V, and X with their left hand, or T, U, M, and B with their right hand. They performed left and right hand trials separately, and they were instructed to perform as many complete sequences as they could in 30 seconds. And it was the number of complete sequences tapped with each hand that was used to calculate the LIZ scores on this task. So the next task that we included was a midline variation of the previous task where the sequences were flipped. So it forced participants to operate with each hand across the midline. And this was used so that we could test for an effect of midline crossing on the ability of the 2 hands. And then finally, we included the complex sequence tapping task. This was designed to closely match the pegboard task used in previous work. And the diagram displays the pattern of presses required on left-hand trials. So on left-hand trials, participants would start by pressing Q, and then Z, and then W, and then X. And they would work across the keyboard in this pattern until they reached M. And then once they reached M, they would work back the other way. And again, participants were instructed to make as many presses as they could in 30 seconds. On right-hand trials, they would start on the right-hand side of the keyboard and initially work leftwards. And on this task, the LIZ scores were calculated using the average time taken for each hand between correct key presses. So, for example, the time taken between pressing Q and Z with the left hand. And to establish the retest reliability, we calculated LIs separately for session 1 and session 2, and then we correlated them. And we pre-registered a cutoff of 0.65 for satisfactory reliability. And this was selected to be consistent with recent work in the area, which also looked at validating online laterality measures, but a different set of measures. And then to assess the validity of the tasks, we tested whether they were lateralized in the predicted direction, and the predictions were based on previous findings with in-person testing. So for the dichotic listing task, we predicted a right ear advantage. For the visual half field task, we predicted a right visual field advantage. And then for the motor tasks, we grouped participants based on their EHI scores. So we had a left-hand preference group and a right-hand preference group. And we predicted that the left-hand preference group would have a significant left-hand advantage on all 3 motor tasks. And then the right-hand preference group would have a significant right-hand advantage. So just quickly, regarding the dichotic listing task, as this had been administered previously by Parker et al. And they established reliability of 0.78, we didn't actually include this in session 2. But the scatter plots show the LIZ scores from session 1 plotted against LIZ scores from session 2 for all the other tasks. And then in the top left corner of each graph is the retest reliability of each measure. So what's particularly impressive is the retest reliability of the simple tapping and the complex tapping task, which came out at 0.83 and 0.84 respectively. And then there's a slight drop off on the midline version of the simple tapping task down to 0.78, but that still exceeded our pre-registered threshold of 0.65. And then the reliability of the visual half field task was less satisfactory and dropped below the threshold and came out at 0.62. In terms of the validity, all of the tasks were lateralized in the predicted direction at group level. So on the dichotic listening task, there was a significant right ear advantage at population level. And also on the verbal visual half field task, there was a significant right visual field advantage. And what's interesting as well is that this was also the case for both hand preference groups. So both left and right handers also showed this lateralization. And then also for the motor tasks, we get this nice bimodal distribution where there's a clear split between the left-hand preference group and the right-hand preference group on each task. And the left-hand preference group had a significant left-hand advantage on all 3 tasks, and the right-hand preference group had a significant right-hand advantage on all of the tasks. And then as a further step to validate the complex tapping task, we correlated LIZ scores calculated from that task with LIZ scores calculated from the pegboard task on which it was based. And this correlation came out at 0.73. So we then used the task to test for an association between sequence-based motor laterality and speech production laterality. And our prediction was based on the findings of Flowers and Hudson. So we predicted that those who were significantly lateralized on the complex tapping task would be more likely to be significantly lateralized on the verbal visual half field task. And to examine this, we used a Cochrane-Mantle-Hansel test. And this allowed us to test for an association between laterality status, so significantly lateralized or not significantly lateralized on the 2 tasks, whilst also accounting for hand preference. And this indicated that there was no significant association. And then to investigate the effect that midline crossing had on motor laterality, we first converted the LIZ scores to absolute LIZ scores. So we dropped the negative sign on all of the negative LIZ scores. And we then ran a two-way mixed ANOVA to look at the impact of hand preference, so left versus right, and task, so the simple tapping task and the midline version of that task, on absolute LIZ scores. Just note that the pirate plot shows the raw LIZ scores rather than the absolute LIZ scores. But we found a significant main effect of hand preference. So left-handers had significantly larger absolute LIZ scores than right-handers. And we also found a main effect of task. So there were larger LIZ scores on the midline version of the task compared to the simple version of the task. And we also found a significant interaction effect. So we then carried out some post hoc t-tests, and these revealed that while left-handers were more strongly lateralized on the midline task compared to the simple task, the right-handers showed no difference in their lateralization between those two tasks. And also that left-handers were more strongly lateralized than right-handers on the midline task, but there was no difference between the hand preference group in terms of strength of lateralization on the simple tapping task. We did a few additional analyses. So we repeated the Cochrane-Mantle-Hansel test, but using the dichotic listening task to test for an association between receptive language laterality and sequence-based modes laterality. And again, we found no significant association, but this was less surprising given the receptive nature of the dichotic listening task. And then finally, we correlated LIZ scores from each of the modes task with EHI scores to look at the concordance between handedness measured using performance measures versus the preference measure. And it was the two simple tapping tasks that were highly correlated with the EHI. So to conclude, the modes tasks all showed impressive reliability, and they're all openly available on Gorilla. The verbal visual half-field tasks reliability was less satisfactory. And one reason that we feel that we may have observed this is because it's quite dependent on tightly controlled viewing conditions so that the stimuli are accurately presented in each visual field. And these are quite hard to monitor with online testing. And then in terms of the null association, it contradicts previous work, but it's important to note several key differences between the studies. I'm going to focus on one here, and that is the fact that the measure of sequence-based modes laterality used previously, which was the pegboard task, involved a grip and release mechanism where you have to grip the pegs and then move it over and release. Whereas on the complex tapping task, they're literally just pressing the keys. So it may be that sequencing that's contained within that element of the pegboard task could be driving its demand for common processing resources with speech. And this is supported by evidence that grip and release tasks, both sequential and non-sequential, show increased left hemispheric activation in neurotypical individuals. And then finally, we observed an increase in the strength of lateralization on the midline task. So in other words, the advantage of the preferred hand increased at group level when participants were tapping sequences across their midline. And it seems that this was driven by an improvement in left-handers' performance with their preferred hand on the midline task. And one suggestion is that this may be down to left-handers' experience of living in a right-handers' world, and therefore they may be more practice in operating in contralateral space with their preferred hand. So I just want to thank the ERC for funding the research, and also the members of COLA who I was lucky enough to work alongside for a couple of years. And then in particular, John, Jess, Adam and Dorothy for their support with this study.
Thank you very much. Any comments, questions?
Thank you, Jack. That was really interesting. You kind of touched on this already, but I wondered if you could expand a little bit more. You had mentioned there were, and showed us that there were reliability issues with the verbal visual half-field task. Was there anything that you had done to try and control for degrees of visual angle online, or was it fairly left to participant screen size and all of those differences? Was that sort of all up in the air? If you could speak to that a bit.
Yeah, so we controlled for that by using, like, the credit card technique where they put their card on the screen and then adjust the size of it to match. So we did control for that, but I think it's more an issue with the way that they sit when doing the task. So in an ideal world, we'd want them in a chin rest so that the image, their head was still the whole time and they were always, their gaze was always in the same part of the screen. But I guess with online testing, that's almost impossible to achieve.
Okay, apparently there are no other questions. Thank you very much again.
Thank you. Thanks.